Okay, hello class. With me again, Sakai here. Okay, in physics, Form 4, Chapter 2. So now we are going to learn subtopic 2.3, free fall motion. So this is a free fall motion and gravitational acceleration. Okay, let's discuss. An object experiences free fall if the motion of the object is affected only by gravitational force. Okay, means kalau free fall motion ni jatuh bebas, dia hanya disebabkan oleh daya graviti sahaja. Okay, this implies a free falling object does not experience the action of other forces such as resistance or friction. Okay, dia tidak akan dipengaruhi oleh daya luar seperti rintangan udara ataupun geseran. Baru kita boleh panggil dia sebagai free fall motion, jatuh bebas yang hanya disebabkan oleh gravitational force, no other force. Okay, so the key point there, only by gravitational force, without experience any other action of other forces such as air resistance or friction. Okay. Sometimes question may ask you what is mean by free fall motion. So this is the answer. Okay. All right. Uh, let's watch a video here. A video about free fall motion. Okay. Wait. Okay. So this is a video about a free fall motion. Let's take a look. Okay. Watch carefully. Okay. Look at the what's the apple and feather. So this video is shown in slow motion. So look at here. Okay. All right. Okay. So when you look at the video, the apple and the feather, tu bulu tu dengan ni apple, dia jatuh serentak. Okay. It falling down at the same time to reach the base. Okay. Actually kalau you tengok, kalau apple ni lebih berat daripada itu bulu, means sepatutnya apple mesti lebih jatuh duluan daripada itu bulu. But in this case, why apple and feather jatuh serentak? Okay, going down at the same time. So this is we call as free fall motion because nanti kita tengok lagi satu video. Okay, baru kita compare. So in a daily life, we see that heavy objects fall and reach ground faster than light object. Okay, macam yang teacher cakap tadi, objek yang berat dia akan jatuh duluan, dia akan sampai ke tanah duluan. Okay, berbanding compared to the light object. Okay, look at this diagram. Okay, the ball bearing for sure kan dia lebih berat berbanding this feather. Okay, motion of falling objects in air. Okay, in air. Okay, next, object of different masses fall with the same acceleration if air resistance does not exist. Okay, if air resistance does not exist, this can happen in vacuum. Okay, vacuum means satu surface ataupun satu permukaan, satu ruang, satu space yang tidak ada udara langsung. There is no air. Okay, means hanya ada gravitational force only. Okay, observe figure 0.2.38. A feather and ball bearing released in a vacuum will reach the floor at the same time. The free fall that you watch in the video in activity 2.4 was actually performed in vacuum. Maksudnya video tadi yang kita tengok apple and the feeder tadi, dia berada dalam keadaan vacuum. That's why dia jatuh dan sampai ke tanah pada masa yang sama. That's we call it as free fall motion, and it's happen only in a vacuum. Okay, satu ruang yang langsung tidak ada udara. So this one lah. Okay, this one in air, maksudnya ada rintangan udara, and this one in vacuum. Let's take a look for this video. Wait, teacher scan dulu. Actually, you can scan your textbook. Okay. Okay. Wait a minute. Okay, let's watch this video. Okay, this is happen with the air in the box. Okay, maksudnya ada udara dekat dalamnya. This one with air. So now dia sudah remove the air, dia sudah sedut. So this is the comparison without air and with air. Okay, watch it properly. Okay, as you can see here, this situation is without air. Okay, this situation is without air, and this situation is with air. So when this situation is with air, means ada itu air resistance. That's why this feather dia lambat jatuh ke tanah. Okay, but the situation is when without air, kan, means there is only gravitational force only. That's why itu air resistance and any other force kita ignore because dia dalam keadaan free falling motion. Okay, that's why berat ataupun the different size dia tetap akan jatuh ke tanah itu dengan dalam masa yang sama. Okay, because there is no other forces. Okay, so the acceleration of a free falling object caused by gravitational force is known as gravitational acceleration. The average value of Earth gravitational acceleration is, so ini average, okay. Biasanya kita akan guna 9.81 meter per second square. The velocity of a free falling object increased by 9.81 meter per second in uniform gravitational field close to the surface of the Earth. When a heavy object falls in the gravitational field, air resistance can be ignored. Ini yang teacher cakap tadi. The object is in free fall motion. Means ni benda, this situation just can be happen in vacuum space. Okay, maksudnya tiada udara. Apa pula maksud dia gravitational acceleration? Okay, when you look at this diagram, okay, let's say this is a ticker tape. Okay, ticker tape. Okay, means ada jarak yang besar sini kan? Okay, so means feeder ini mengalami experience and acceleration. Same goes to ball bearing. Okay, when you do a dot, and this dot, so this distance show us there is an acceleration happen. Okay, that's why we call it as gravitational acceleration. And average for the average value is 9.81 meter per second square. Okay, alright. The value of gravitational acceleration g, we call it as g, not a, change from one place to another. For example, the value of g at the equator is 9.78 meter per second square, while the value of g at the earth poles is 9.83 meter per second square. This is because earth is actually not a perfect sphere. Okay, actually you boleh tengok sini. North Pole, the value of gravitational acceleration is 9.83. But here, the gravitational acceleration at the equator is 9.78 meter per second square. So why there is difference in these two value? Okay, let's take a look. Shows that distance from the equator to the center of the earth is further than distance from the poles to the center of the earth. As such, the value of g is smaller at the equator than the earth's poles. Generally, the value of gravitational acceleration on the surface on the earth is okay, so no problem. Okay, why there is difference here? Because you tengok dia punya distance, right? We look at the distance at the equator here. To distance from equator to the center of the earth is 9372, while distance from pole to center of the earth is 9350. That's why equator distance from the equator to the center of the earth is further than distance from the poles to the center. That's why di sini dia akan mempengaruhi, it can be affected by the value of g. Okay, mana lebih jauh? Distance pole kan? Pole lebih jauh. Equator lebih jauh daripada itu North Pole from the center of the earth. That's why semakin dekat dengan ni center, semakin tinggi dia punya value of g. Semakin you jauh, okay, this one is lebih jauh kan? That's why dia punya value of g is rendah daripada value of G in the North Pole. Okay, means kalau you makin dekat to the center of the Earth, the acceleration is increase. Okay, makin kuat itu tarikan gravity. Kalau kita jauh daripada center of the Earth, that means dia punya value of G is smaller. Okay, maksud dia dalam kita punya sphere ni, dalam kita punya Earth, bumi ni, setiap sudut ini berlainan value of G. Okay, because difference of distance, so difference value of gravitational acceleration. Alright. So that's all for the concept of free fall motion. You have to know what is free fall motion, what is gravitational force, and the last one is gravitational acceleration. Free fall motion means itu objek jatuh without any other forces acting on it. And gravitational force means satu daya, a force that towards downwards. Okay, itu gravitational force. And last one is gravitational acceleration. Different places, different distance, so we got different value of gravitational acceleration. Then we go to the next subtopic. The next lesson is about solving problems related to free falling objects. Okay, objects thrown vertically upwards or released and falls downward experience gravitational acceleration G. Therefore, the equation of linear motion below can be applied to free falling objects. Actually, kita sudah belajar this formula, cuma let's say this one, this A we change to G because we consider the gravitational acceleration. Same goes to here. Actually here is A kan, but we change to G also here because we consider the gravitational acceleration situation. So in solving problems, our assumptions are upward motion is motion in the positive direction, this one. Okay, and downwards motion is motion in the negative direction. Means dia punya, kalau kita consider the displacement kan, kita baling satu objek pergi atas means dia punya displacement is positive kan, but when the object is falling down, the displacement itu become negative to show the direction. Alright, objects thrown upwards, our assumption is motion in the positive direction. And then object released downwards, our assumption is motion in the negative direction. Alright, let's take a look at the example. Example 1, Amira threw a ball vertically upwards with an initial velocity of 10 meter per second. Calculate the time for the ball to achieve maximum height. Means dia buang itu satu bola, ini tangan dia kan, so you buang, so confirm ni bola akan jatuh semula kan. Okay, setiap objek yang kita umban ke atas, dia pasti akan jatuh ke bawah. Okay, ini situation dia. Alright, so the first question is time for the ball to achieve maximum height. The second one is maximum height that can be reached by the ball. Okay, first cari time. The second one is dia punya height, so displacement dia lah. So let's check for question A. Step 1, list the given information in symbols. Okay, symbols kan, ataupun sign kita kena tulis. So initial velocity is u equal to 10 meter per second, already mentioned in the question here. And then final velocity at maximum height, v is equal to 0 meter per second. And acceleration g is negative 9.8 meter per second square. Okay, ini kita punya average acceleration kan. Memang kita guna negative 9.81. Alright, mesti ada yang tanya why the value of v here is 0. Okay, actually the question is already stated there. To achieve maximum height means kalau you umban satu ball kan, so pergi atas dia mesti akan stop sekejap baru dia jatuh. So that's why maximum height dia di sini dia akan stop. So the final velocity here is 0. Again dia akan baling itu bola, dia punya laju is 10 meter per second. And then when it reach the maximum height, okay, dia akan stop ni baru sebelum dia jatuh. Okay, this is the final velocity when it stop. Okay, dia tanya yang maximum height. So here, so this is we let as final velocity. Okay, that's why v equal to 0 meter per second. Okay, so step 2, identify and write down the formula used. So of course kita sudah ada v, we already have u, v and g. So now time to find t. Okay, you just manipulate the value, okay, and then you will get 1.02 second. So remember here the formula still plus, but here it become negative because when you substitute the value of g is negative 9.8. Okay, teacher tulis 10 plus negative 9.81 times t. So positive with negative dia akan jadi negatif. Okay, that's why dia jadi begini. And then you manipulate, you akan dapat 1.02 second. Okay. Question B, maximum height that can be reached by the wall. So apa formula yang ada S? Okay, S ada dua. Either you guna yang S ut plus 1 over 2 gt square or v square u square plus 2 gt. So you can choose mana-mana lah. Okay, depends on the information that you have. So here dia guna v square. Oh, sini s pula, sorry. So actually you should have the v, value of v is 0, u is 10. Okay, 10 square plus 2 negative. This one you just insert to the formula lah. And then you akan dapat 5.10 meter. Or you can use this formula. Macam teacher cakap tadi. Also you can get the same answer. Okay. Alright. Example 2. Chan released a stone from a cliff of 10 meter height. Determine the time taken for the stone to reach the bottom of the cliff. Okay. Means Chan. Right. Sini si Chan. Okay, this is Chan. Dia throw a stone. Ni batu dia buang pergi bawah. Okay. Means this one is 10 meter height. Determine the time taken for the stone to reach the bottom of the cliff. Time taken. So kalau time taken kita ada berapa formula? Kita boleh guna this one or this one. Okay, depends on the information given. Kalau kita menggunakan this formula cannot because kita tidak tahu v, kita tidak tahu u, tidak tahu dia punya itulah yang kita tidak tahu. Okay, tapi dalam soalan ini dia sudah bagi 10 meter, means this 10 meter is refer to displacement. That's why this solution use this formula. Okay, S equal to ut plus 1 over 2 gt square. So the value of S here is negative 10. Why negative 10? Because the displacement of this stone going downwards. Kan? So our assumption is it go to negative direction. That's why the displacement is negative 10. Initial velocity is 0. Right, teacher? Macam mana pula initial velocity boleh 0? Because first si Chan pegang ball kan. So this is the initial velocity. Dia belum bergerak. And then after they release to stone, so okay, itu baru kita panggil dia V, final velocity. So that's why kita assume the initial velocity masa dia pegang tu belum lepas, kita assume dia sebagai 0. Okay. Alright. Then T 1 over 2. So G, the value of G is negative 9.8 times T square. So negative 0 times T kan, of course lah 0 kan. So here 2 they bring to here. This 2 it brings to here. That's why 2 times negative 10. And then negative, okay, like this. So to find T, mesti ada ini ya. Kita coba lah. So dia akan jadi negative 20. Negative 20. This one ah. Negative 9.81 T square. So now we need to find the T square. Okay. So T square negative 20 over negative 9.81. So to find T square root, kamu kena letak plus minus because there is two possibilities of answers. So negative 20 over negative 9.81. So just press your calculator and then you akan dapat dua value. Satu 1.43 second and another one is negative 1.43. Okay. So why we choose the positive number? Because kalau masa mestilah dia punya value is positive kan. Mana ada masa value dia negatif. That's why we mention here T equal to negative 1.43 second is ignore. You kena mention juga this one. And then this is the chosen one. So 1.43 second. Okay, next. The velocity of the stone just before it touch the ground. Okay, just before it touch the ground. Okay, belum dia sampai itu tanah kan. Velocity. Okay, maksud just before it touch the ground kan. This one. Ini tu ground kan. So ini stone dia buang. So at first dia punya U is equal to 0 meter per second. So kita mau this one. Velocity sepanjang pergerakan dia ni sebelum sampai ke tanah. So V. V ini yang kita mau cari. Okay. So based on the information given, we choose this formula. V square U square plus 2GS. Just substitute to the formula. So U so look at here. U here is okay 0 square. Initial velocity is 0 kan, plus 2 negative 9.81 times negative 10. Why negative 10 here? Because the direction of the stone is going downwards. That's why it's negative 10. And then you manipulate, dia akan jadi this one macam yang kita buat tadi. 2 times negative 9.81 plus and times negative 10. So you should put this plus minus. Okay, so after you calculate, you will get plus minus 14 meter per second. Okay, so which value kita kena choose, positive 14 or negative 14? Okay, obviously velocity is a vector quantities kan, so kita kena ambil dia punya magnitude and dia punya direction. That's why here we choose the negative answers, negative 14 meter per second, and then the positive one, positive 14 meter per second is ignored because the stone move downwards. Okay, that's why we choose the negative answers. Okay, so the problem here is jangan careless, don't careless about the sign. So you kena refer itu situation betul-betul, either going downwards or upwards. Okay, that's why when you substitute the value to the formula, dia akan effect to the answers. Okay, so that's all for today. See you to the next class. So I will give you an exercise. Okay, here. No, no, no. I give you in picture. Okay. So bye bye. Thank you.